Okay guys, so this is part 2 of the inverse question. I had to stop recording because the bell rang and I had to start class, and as you notice there was a lot of interruptions, and so I apologize for that. Just to reiterate what we went over, okay, we found your original function and its inverse. Okay, the inverse undoes whatever is being done. So if at the beginning we multiplied by 3, your inverse is now going to divide by 3. But at the beginning in the original function I was adding 7, your inverse function subtracts 7. And then your original function was dividing by 8, so now we're multiplying by 8. So as you go through the process, you end up undoing what you were doing originally to just kind of get the opposite. If you look at number 3, the original function was x plus 5, your inverse is x minus 5. And if you look at number 1, you would expect it to say x divided by -1, maybe minus 5, but we end up getting the same function. The original function and its inverse end up being the same. Okay, so let's practice a little bit more. Let's look at number 4. Number 4 is fairly easy. Don't let the square root symbol freak you out. Okay, if first step is to switch x and y. And I guess I cut off the steps, but I'm assuming you already know. Switch x and y. Solve for y. Replace y with f to the -1 of x. This means inverse function. Okay, so if you switch x and y, everything else stays the same, and you're left with x is equal to the square root of y plus 4. The next step is to get rid of the square root symbol. In order to get rid of a square root symbol, we have to do the squared. So when you square a square root, you end up getting rid of the square root symbol. Everything else stays the same, so you're left with x squared is equal to y plus 4. The square root of y plus 4 squared just leaves you with y plus 4 is equal to x squared. And now I need to get y by itself. So what we're going to do is we're going to subtract 4 from both sides. And subtract 4 from both sides. Sorry, I kind of ran out of space. I probably should have written it over here. So x squared equals to y plus 4. You subtract 4 from both sides, and you're left with x squared minus 4 is equal to y. Okay, we're going to replace the y with f inverse of x. So the inverse function is x squared minus 4 for the square root of x plus 4. Are there any questions? Okay, if you have a question, you can go ahead and put it in the comment section, and I'll be glad to answer it. Okay, all right, so let's go to number 5. Number 5, the first step is to switch x and y. I'm going to write x and y. Everything else stays the same. Okay, and what you want to do is you want to get y by itself. So I'm going to add 9 to both sides, and you're left with x plus 9 is equal to y squared. In order to get rid of the squared, you have to take the square root. So you're going to take the square root of both sides, and everything else stays the same. X plus 9 equals to y squared. The squared and the square root, they end up canceling each other out. And so your final answer is that y equals to the square root of x plus 9. You want to replace y equals with f inverse. So the inverse of x is the square root of x plus 9. Okay, and number 6, to finish this video off, is you switch x and y. Everything else stays the same. And you guys should know how to solve this by now. The first thing you want to do is subtract 19 from both sides. you're left with x minus 19 equals to negative y. You want to divide both sides by negative 1. So y equals to x minus 19 divided by negative 1. Okay, you want to rewrite this as negative x plus 19 is equal to y. The only thing I did was to divide x by negative 1, which gave me negative x, and negative 19 divided by negative 1, which gave me a positive 19. This answer is also correct. They are equivalent to each other. Okay, and then the very last step is to replace the y with f inverse. There will be a question on your test on inverse functions. And if you notice, the cool thing about number 6, the inverse and the original function are the same.